Okay, so our assignment today is graphing systems of linear inequalities. We have graphed linear inequalities before, but we haven't actually done a system. We haven't done two at one time. And we've graphed lines before, but they weren't inequalities where we had to actually shade. So I'm using two different colors here so you can see what I'm working with. Before I can graph, I'm working with the red one here. I put red stars. Before I can graph this, I have to solve it for y first. All right, so to solve this one for y, we're going to divide by 5 on both sides. And when I do that, I'm going to get y is greater than 2 divided by 5 does not reduce, so we're going to leave that as 2 over 5x. And then 10 divided by 5, that reduces to positive 2. Okay, and so we'll go ahead and graph that one. So to graph this, first thing we want to always graph is our y-intercept here, which is positive 2 on the y-axis. And our slope here is 2 over 5, positive 2 over 5. Positive slopes go up and to the right. So we're going to go 2 over 5. We're going to go up and to the right. Up 2 over 1, 2, 3, 4, 5. We're going to put as many coordinates as we can. Up 2, 1, 2, 3, 4, 5. Okay. Instead of going up and to the right, we can also go down and to the left. Down 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. All right, and so now whenever I connect these dots, remember if it's an inequality, if there's an equal to line underneath it, it will be a solid line. Here there's no equal, so we are going to have a dotted line. Connecting my dots, and I'm also going to have to shade. All right, we have a greater than. Greater than means we are going to shade down. So I'm going to shade all this down below my line. Okay, now the other line. Again, we need to solve for y. So we're going to add 4x to both sides. So I've got y greater than or equal to. I only flip my sign if I divide by a negative. Okay, so slope-intercept form, I want to put my positive 4x in the front, and then I'll move my positive 8 to the back. Okay, so we are ready to graph this one now, since y is by itself. Again, we always plot our y-intercept first, so we're going to plot 8 first. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's our starting point. And our slope here is positive 4, or 4 over 1. Well, if I go up 4 and to the right 1, positive slopes are up and to the right, I'll go off the graph. So I can always go down 4 and to the left 1. 1, 2, 3, 4, left 1. Continue. 1, 2, 3, 4, left 1. 1, 2, 3, down 4, left 1. 2, 3, 4, left 1. Okay? And now here, since this does have an equal to, this one is going to be connected with a solid line. Put your arrows on the ends of your line. All right, and here we have a greater than. So a greater than inequality sign tells us we're shading up. So I'll put my pencil on this blue line, and I will shade up above the line. Okay, so everything up above the line is what gets shaded here. Now my solution. Okay, it says determine which points are in the solution. A solution is a coordinate that falls in the double shaded area. Well, down here on the bottom right, this is only shaded red. Up here on the top left, this is only shaded blue. So my double shaded area, where I have red and blue shadings, okay, it's going to be right here in this section. So I'm looking for any of these coordinates that land in that section. Okay, now, if it lands directly on a line, if it lands directly on a solid line, that is good. It is equal to that line. It is equal to, that is good. If it lands directly on a dotted line, that does not count. That is no good, because that is not equal to. All right, so let's check these coordinates. I've got -5, -3. So we'll start from the origin. 1, 2, 3, 4. -5, 1, 2, 3. -5, -3 lands right here. Yes, that is in my double shaded area. So I will circle him. He's good. -3, -4. 1, 2, 3, 1, 2, 3, 4. This one lands right on the solid line. If it lands on the solid line in that double shaded area, that is also good. If it landed on the dotted line, it would not be good, but that one is good. Negative 5, 0. Negative 1, negative 2, negative 3, negative 4, negative 5, 0 lands right there on the red dotted line. Dotted line does not count. He's no good. It has to be completely in the shaded area, or it has to be on a solid line connected to the shaded area. Negative 4, positive 3. 1, negative 2, negative 3, negative 4. 1, 2, negative 4, positive 3 is up here. That is only in the blue shaded area. That does not count. Negative 6, negative 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 1, negative 2, negative 6, negative 3. That does fall in the double shaded area, so that is a good solution as well. Only good solutions are the ones that fall inside the double shaded area. Flip it over to the back. Okay, now they have given me the graph already, and it's my job to write the system here. So we know it's got to start with y. All right, so my red line is the one that has the red stars on either side of it. Okay, well, what do you notice about this? I notice that it's shaded down below the line. All right, so if it's shaded down below the line, that's going to be a less than, shaded down. And I notice my line is solid, so that's going to be also equal to. Okay, now I just need to know what the equation of the line is. So if I find a couple coordinates, I can find the slope. I know this dude's going down and to the right, so the slope has to be negative. Well, the slope is 1 over 1. 1 over 1, 1 over 1, 1 over 1. So it's negative x, or negative. If you want to put negative 1x, you can. Or you can just put negative x. Either way is fine. And now all I need is the y-intercept. That goes at the end. The y-intercept, this one crosses at positive 2. So we'd say plus 2. So there's the equation of that inequality. Y is less than or equal to negative 1x plus 2. Or you could just say negative x plus 2. All right, so we look at the next line, the blue one. Okay, the blue one has the blue stars at the end of it. I know we always have to start with a y. This one is shaded. It looks like it is shaded down below the line. Down below is going to be a less than. I know my line is solid, so that's also going to be equal to. So now I just need the equation for this line. This slope has a positive slope. He's going up and to the right. So if I count from one coordinate to the next, I go 2 over 1. 2 over 1, 2 over 1. Well, 2 over 1 is really just 2. Okay, and remember my slope is my m. It's always attached to the x. Okay, so 2 over 1, we don't really need to put that as a fraction. So y equals 2x, and then where does it cross the y-axis? That's our y-intercept. It crosses the y-axis at negative 1, negative 2, negative 3 is where this guy crosses the y-axis. So we'd put minus 3 there at the end. Okay, so we should be able to go both directions with these systems. First of all, if they give you an equation, we should be able to graph it like we did on the front page. And here, if they give me the graph, we should be able to write the equation here. So examples 1 and example 4 are for you on your own. We will probably look at those in class. And then we've got our homework assignment that we will work on in class as well.